All right, boys. Today, third section, this is where things actually get a little bit difficult. This one's pretty complicated. So this is multiplying matrices together, not by a scalar product, but like one matrix times another matrix. Okay, so if you read this top part, I need some pen action. Okay, so if you read this top part, it says the product of matrices A, n by n matrix, and B, an n by p matrix, is the m by p matrix whose element in the eighth row in the bth column is the sum of the products of corresponding elements of the eighth row of A and the bth column of B. What that means? Nothing. However, I can translate it pretty well. So in order to multiply two matrices, the key to this whole thing is you have to have the same number of columns in the first matrix as the number of rows in the second matrix. Okay? That has to be the same. That's the key, the ends. All right? And then the other thing that you could notice about this so far is that your result is going to be an m by p matrix. So your result should have the number of rows in the first matrix and the number of columns in the second matrix. Okay? Remember, the columns in the first matrix, rows in the second matrix have to be the same. The other ones don't really matter that much. All right, so in order for that to happen, basically you're going to multiply all the numbers in the rows of the first matrix by the numbers of the columns in the second matrix. All right, and then you add all those together. It's not too big of a deal once you get the hang of it, but the key is this setup, okay, because you need to know when you can and when you cannot multiply two matrices together. The easiest way to show this is just by obviously doing a problem, so I'll get there in just a second. I also want to tell you about that other special type of matrix that we talked about. Okay, you want to always leave, when you're naming matrices, you want to leave O and I blank, because the O we obviously already talked about is a zero matrix, and the I is called an identity matrix. Okay, so the identity matrix is going to be useful here and from here on out. Okay, it has to be a square matrix. Okay, so you could do a 2 by 2 one. All right, and it's a matrix when everything's a zero except from the diagonal from the top left to the bottom right. All of those are ones. Okay, so for this one, the diagonal from the top left to the bottom right are all ones. Everything else fills in a zero. All right, so the identity matrix for 4 by 4. I mean, you could do a 3 by 3 obviously also, but just want to mix it up. Okay, so that means we got 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. Okay, so you notice here, hopefully, that this diagonal is all ones, everything else is 0. That diagonal, all ones, everything else is 0. Okay, so you could do that. That's going to be helpful later on. This is just something, a term that we need to know right now. I'll show you how to use it later. Now, the examples here, multiply if you can. Of course, if you don't have the correct number of rows and columns in the two matrices, then you can't do it. So remember, the key for this is columns in first equals rows in second. Have to have that in order to do this. So in this first one, how many columns do we have in the first? We've got 2. How many rows do we have in the second? We've got 2. That means we can do the problem. So that means that we can begin to multiply, right? So what you are doing here is something called the dot product. You don't need to necessarily know that, but the idea behind the dot product is you multiply, all right, the elements from the first row and the first column. Okay, so you multiply the corresponding ones together, and then you add the two answers together. All right, when you do that, you're going to come up with the first row and the first column. Okay, so that means that we will get 1 times 3 equals 3. So 1 times 3, right, equals 3. And negative 1 times 2 equals negative 2. When you add those two up, you get 1. So that tells us that the element of this product, right, in the first row, because we've got the first row here, and the first column is 1. All right, to do the second one, we do the second row and the first column, because we only have one column here. All right, so when we do that one, we've got 2 times 3 equals 6. 5 times 2 equals 10. All right, add those up, you get 16. So that means the element in the second row and the first column, okay, second row, first column, is 16. And that is the final answer. I know that's tricky, but we'll do a couple more examples and it should be okay. So the second one, if we want to do that, we have to make sure, of course, that we've got the same number of columns in the first as number of rows in the second. Do we have that? Well, we've got one column in the first matrix, but only two columns in the second one. That means that you can't do this problem. Okay? Notice that this is the same problem. 1 and 2 are the same problem, just flipped. Right? You just flip the numbers. It doesn't work that way with matrices. You can't just flip the order of the matrices and necessarily be able to do it. You have to always have the same number of columns in the first as number of rows in the second. So this just ain't no solution. We're done. Now, third one, back to real business. All right, do we have the same number of columns in the first as rows in the second? Yes, obviously we do. You've got 2 columns in the first, 2 rows in the second. So we can get to work. All right, so we begin by multiplying the first row by the first column. That's going to give us our first element. Okay? I'm going to do that. You got 0 times 1 is 0, plus 2 times negative 2 is minus 4. Good. All right, if we do another one, all right, so you still got first row, second column. All right, first row, second column, multiply it out. We've got 0 times negative 5 is 0, plus 2 times 0 is 0. So that means the first row, second column is 0. And lastly, first row, third column. First row, third column, multiply 0 times 4 is 0, plus 2 times negative 6 is negative 12. Hopefully you see that. Now, we can do the exact same thing with the second row and the third row. So we're going to end up with a 3 by 2 matrix, or 3 by 3 matrix. All right, so we multiply second row, first column. We got negative 2 plus negative 8 is negative 10. Second row, second column. All right, positive 10. Negative 2 times negative 5 is positive 10. Plus 4 times 0 is 0. So we got a positive 10 there. And lastly, second row, third column. Negative 2 times 4 is negative 8. Negative 6 times 4 is negative 24. So we're going to have negative 32. And same thing with the third column and third row. Okay, third row, third column. Or third row, first column, I apologize, is 3 minus 2 is 1. The second one is negative 15 plus 0, so it's negative 15. And the third one is 12 minus 6, which is 6. That is the correct answer. All right, one last try. I know that one's a lot more complicated, but if you just follow the pattern, it works out pretty easily. Now lastly, we've got this 1 by 3 matrix multiplied by a 3 by 1 matrix. Because you've got the same number of columns as rows, it works out. You can do it. Okay, so if we want to multiply this, this one's pretty easy. You just multiply the row by the column. It's going to end up with a 1 by 1 matrix. Not a whole lot you can do here. So 1 times negative 2 is negative 2. All right, we've got 2 times negative 3 is negative 6, and 3 times 1 is 3. So when you simplify that, you're going to get negative 8 plus 3 is negative 5, and the answer is indeed negative 5. So that's it. Good luck.